Assalamualaikum warahmatullahi wabarakatuh. My name is Fatih Farahia as the project manager of JARVIS company. We would like to present about our field exploration project in Rumandawi. First of all, I would like to introduce our company background. JARVIS is a simplified form of an acronym from just a rather very intelligent system. It is an indigenous service provided to the oil and gas industry in Malaysia. Moreover, it is incorporated as a limited liability company in Malaysia in 2013 to carry on the business of drilling support for the oil and gas industry, environmental management, marine logistics and support, and project management. Next, I would like to introduce the board of directors of JARVIS company, which led by me as the project manager and geologist, and then Ahmad Haikal as geophysicist, Nurwani as petrophysics, Umi Zulaika as geologist and economist, Alia Shakirah and Siti Nurhayani as reservoir analyst. Without further ado, I would like to move on to the geological part of Rumandawi field. Rumandawi field is located in Sabah Basin, which is 350 km length and 140 km width for the geological area. Its formation is located in the offshore of Kota Kinabalu, consists mainly tertiary siliclastic sediments. The source rock of the Rumandawi field is mainly from shale with reservoir structures of anticlines. As you can see from the figure 2.1, the basement of Rumandawi field in Sabah is located northwest of Kota Kinabalu. From this location, you can see Rumandawi field is located in the block SD2T from the figure 2.2, which has been marked as the red spot. Next, I would like to move on to the geological history of the basin. Sabah Basin consists of 80% marine or offshore deposits toward the South China Sea. The basin is about 350 km length and 140 km width with thickness of about 10 km of mostly tertiary siliclastic sediments. It is an offshore, predominantly middle Miocene age sedimentary basin that underlies the continental margin of western Sabah and continues to the Sabah Troop and the dangerous ground provinces. As you can see from the figure 2.3, the Rumandawi field is located in the inbound Sabah, which is located at the northwest part of the Sabah state. In middle Miocene, a regional uplift at the end of the subduction caused erosion of Rajang fault belt, resulting a regional unconformity at the landward margin of the basin. Later, it was followed by northwest progression of coastal to shallow marine clastic sediments in middle Miocene to early late Miocene. The basin was subjected to a sedimentary deformation since middle Miocene, which resulted in numerous narrow north-northeast, south-southwest trending of anticlines and deep broad synclines. As you can see from the figure 2.4 lithostratigraphic scheme of Sabah Basin, the Malikai and Kebabangan and also Kinarut, which is located nearest to the Rumandawi field. The Rumandawi field was formed from an anticline structure. It also has a reservoir capped rock as shale. Moreover, the hydrocarbons are found in unconsolidated sandstone with an average porosity of about 16%. The lithology of Rumandawi mainly consists of three main rocks, which is limestone, sandstone, and shale that overlaying each other. Besides, the neighboring fields for the Rumandawi is firstly Kebabangan field. Kebabangan field is located in the South China Sea, which is at 130 km offshore Sabah, East Malaysia. It is also part of the Kebabangan cluster, which contains two more fields of Kamunsu East and Kamunsu East Upthrown Canyon. Its ownership consists of Petronas Jarigali at 40%, ConocoPhillips at 30%, and Shell at 30%. It has been discovered in 1994, which reserved 2.2 trillion cubic feet. And then the production has started back in November 2014 with its operator as Kebabangan Petroleum Operating Company. The water depth at the cluster ranges from 100 meter to 400 meter. Next is Kinarut field. It is in block XB301 offshore Sabah. and approximately 37 km northwest of the existing West field and about 100 km northwest of Kota Kinabalu. Its operator is Petronas with type of reservoir as oil and gas. And then the estimated gas reserve is approximately 350 billion cubic feet. And that's all for the geological part, and move on to the petrophysics, which will be led by Nurwani.
Hello and Assalamualaikum. My name is Nurwani binti Mamazaki and my role is in this JARVIS company is as petrophysician. First, I will explain about the well correlation of Rumandawi. There was 4 wells in Rumandawi which are labeled as RDW01, RDW02, RDW03 and RDW04. Since all of the well were sunk in the same reservoir, each well provides its own logging data which may connected with another. The correlation demonstrates the reservoir, lithology and productive strata. Correlation between wells is depicted in the figure 3.1. Our reservoir is stocked with 11 permeable zone and sandstone and shale as the dominant lithology. Next slide shows the interpretation of each well correlation, which both RDW01 and RDW02 have 11 faces, while RDW03 and RDW04 have 8 faces. From the table of interpretation of this well correlation, we can see that most of the gamma ray log shape are blocky and irregular blocky. Most of the blocky shape is shale and irregular blocky may be interbedded sandstone and shale. Next slide is for porosity evaluation. We calculated the value of NPHI and RHDB in 5 depth in meter, which is 6088, 6100, 6190, 6200, and 6300. And we also calculated the average value of NPHI and RHDB to get the average porosity. Then all the value will be plotted on the plot diagram as shown in figure 3.7. Table 3.2 shows the summary of porosity evaluation in Rumandawi, well, which we can see that overall Rumandawi is dominated by sandstone. Next slide is for sandstone thin section. First, the type of the rock is sandstone. The percentage of porosity 92%. Type of porosity intergranular. The permeability of this sandstone is good permeability. The major composition of rock quartz 78% and lithic 16%. Mineral heavy metal 4%. And for the next slide, the type of the rock is also sandstone, 23% of porosity. The types of porosity is intergranular. This sandstone is a good permeability and major composition of this rock is also quartz and lithic. That's all for me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Ahmad Haikal bin Mutafaruddin and I am the geophysicist for this group. So about the seismic interpretation, we can see there are anticline structure here which sealing cap and entrapping the petroleum alkali. There are faults indicating the controlling of the oil enrichment, and we can see here the gaseous substances released migrating from below and stop below anticline structure that entrapping the hydrocarbon itself, which we can indicate here this area is full, is rich with hydrocarbon. About the difference between the color, we can see red and blue color. This color shows the impedance of the faces itself of the sandstone, of the mudstone. Okay, next, we can see here there are 5 kind of faces, 5 bedding here, and this area is considered as regional syncline and anticline. Bedding 1, 2, 3, 4, and 5 yanging upward. Bedding 1, 4, and 5 are permeable and porous. Bedding 3 with poor permeability and porosity, while bedding 2 is impermeable and non-porous to water and hydrocarbon. And we can see here that both normal and thrust and also reverse fault present here.
I'm Umi and I'm in charge for the economy part. So what is program pyrolysis? It is also known as a rock eval. It provides organic geochemical data about the type of organic matter, and the samples are usually subsample from the freeze-dried material previously crushed for analysis on the coulometer and CNS. So this is the pseudo-band prevalent diagram. Plot of Hi against OI. It shows a type 2 kerogen which is characterized by slightly lower Hi and higher OI value than that of type of 1 kerogen, typically attributed to marine tectonic sources, and it is also oil prone. So from an economic perspective, type 2 kerogen has more generative capacity than type 3 kerogen. For any given thermal maturity, types 1 and 2 kerogen will generate more liquids or oil than type 3 organic matter. So to determine the kerogen type and maturity, I've plotted the diagram as shown on the right side, Hi versus Tmax. So Tmax is an indication of the stage of maturation of the organic matter where the CO2 issued from kerogen cracking is trapped in the 300 to 390 degrees Celsius range. And immature organic matter, as most of the Tmax values are uh, less than 400 degrees, it indicates a low thermal maturity. It is commonly considered to be associated with sample contamination or other factors that can affect the number of hydrocarbons generated through thermal cracking of a non-volatile organic matter. So it is clearly shown that type 3 kerogen, which is considered as a gas transaction, are from the graph. And lastly, to determine the kerogen quality, we have plotted a Hi versus TOC graph. The relationship between Hi and TOC shows that carboniferous source rock of Sungai Perlis Basin have a good source potential, and it is suggests that it is predominantly a gas generation potential.
Engineering principles are used in reservoir engineering to assess and manage reservoir. Reservoir engineers aim to increase hydrocarbon output and maximize exploration and production assets through reservoir analysis studies. Subsurface geology, applied mathematics, the fundamental physics and chemistry rules regulating the behavior of liquid and vapor phases of crude oil, natural gas and water in the reservoir rocks are the working tools. The behaviors of a naturally heterogeneous reservoir can be fairly represented by reservoir characterization. The reservoir performance in terms of well rate, reservoir pressure and final recovery may then be predicted using it with high reliability. This process is highly important as the economic viability of a petroleum recovery process is greatly influenced by the production performance of a reservoir under current and future operating conditions. This is the flow interest of gas, oil and water formation. Resistivity nomograph, which is corrected RMC and RMF. Direct measurements of mud filtrate resistivity RMF and mud cake resistivity RMC samples are preferred. The accurate determination of RMF and RMC are necessary to calculate the formation porosity. The figure shows both corrected result by using resistivity nomograph, which is corrected RMF 0.135 and the corrected RMC is 0.125. The figure shows the chart and nomograph used to calculate the equivalent formation water resistivity RWAC from the static spontaneous potential ESSP measured in clean formations. 5 depths of ESSP were used, which are 6,088 feet, 6,100 feet, 6,160 feet, 6,200 feet, and 6,300 feet. The figure shows the RWAC result obtained from all the selected depths, and calculations were shown on the calculation. The figure shows the value of RWAC is used in chart SP2 to determine the resistivity of the formation water, RW. RW is used in Archie's water saturation equation. Formation of hydrocarbon and water contact. For the hydrocarbon depth, we have chosen a depth of 6,200 feet. Meanwhile, the water contact between hydrocarbon is 6,436 feet. From the log LLD, LLS, and MSFL, the values obtained are 19, 1, and 0.5 respectively for the hydrocarbon, while the values obtained for LLD, LLS, and MSFL water are 1.2, 1.1, and 1. The figure shows the corrected result, RLLD, deep lateral log borehole correction, RLLS, shallow lateral log borehole correction, and RMSFL, mud cake correction. The calculation used in order to obtain RLLD corrected, RLLS corrected, and RMSFL corrected for hydrocarbon at depth 6,200 feet. The calculation used in order to obtain RLLD corrected, RLLS corrected, and RMSFL corrected for water contact at depth of 6,436 feet. Dual lateral log RXO and RWS. Based on the corrected values from RLLD corrected, RLLS corrected, and RMSFL corrected, RXO and RWX can be obtained. RXO is basically the value that is represented for hydrocarbons by using RT value. Meanwhile, RWS is basically the value that is represented for water by using the value of RW. To obtain both RT and RW, dual lateral log RXO and RWS were used. The figure shows the result obtained for hydrocarbon with the red circle and water with the yellow circle. The calculation is used in order to obtain RT and RW values.
Next, we have the water saturation. For the water saturation, it's actually the most challenging of the petrophysical calculation and also being used to quantify its more important complement, which is the hydrocarbon saturation. The basis of RT equation is conventionally used to calculate the water saturation of a formation. Is that the conductivity of the formation is a function of the conductivity of the fluid content in its pore space. So the calculation shows for the calculation of water saturation by using both result from RT and also the RW. So next, we have the subsurface mapping. So basically, subsurface mapping is a map that depicting the geologic data of features below the earth surface, such as a structure contour map of the petroleum reservoir. The maps and subsurface data are important to identify an area for more detailed exploration when looking for the new resources. A number of geophysical techniques are then used to obtain more information about what lies beneath the surface. So for the subsurface mapping, there are 4 types of maps that produced by using the data given. First, we have unconformity. Second, top reservoir. Third, we have base reservoir. And last one, we have the pay map. Okay, from combining for unconformity, top reservoir, base reservoir, and also the pay map, we can illustrate the block exploration that produced by combining cross-section from all the maps. So basically, the unconformity maps is used as a benchmark to divide the bedding. Next, there are 3 sections of missing depth in the top reservoir map that may be caused by the erosion.
Hence, the missing depth was marked with a dashed line on the map due to the uncertainty. Then the base reservoir map is a map that shows the lowest part of the petroleum found. Okay, for this map, faults were found, and when the top reservoir and base reservoir changed were out of the alignment. This is because at the site, the bedding has changed its original position due to the fault. Next, the use of baymat is very important to determine the section or at what depth there is oil, gas and water. So based on the cross section from the top reservoir, base reservoir and also the baymat, there are three sections that are found with depth. So for the GOC, we found it at the 7655 feet. For the GOC, we found it on the 7750 feet. And also for the OWC, which is oil water contact, we found it at the 7950 feet. Okay, for the last one, we have the STB, which is, we call it as the stock tank per barrel. Stock tank per barrel is basically a standard measure of oil volume and being equal to about 159 liters. Okay, based on the calculation given, original oil in place, which is OOIP, which is referred to the total volume of hydrocarbon stored in a reservoir, was calculated in order to get the volume of oil at Rumandawi, which is about 3.165 power of 13 STB.